Locating real zeros of polynomial functions. In this section, we will find the zeros of higher order polynomials using synthetic division and the rational zero theorem. So let's start off with that theorem. If f of x is equal to some polynomial in standard form with integer coefficients where a sub n is not equal to 0, then any rational zero of f must be of the form p over q, where p is a factor of the constant a sub 0 and q is a factor of the leading coefficient. So what this does is it leads us to a way of finding possible rational zeros. So let's go ahead and take a look at an example. So the process is to find the p's and the q's. The p's are factors of the constant term. So in this case our constant term is -3. So the possible p's would be all of the factors of 3. So that would be 1 and 3. And then q is the factors of the leading coefficient, which in this case is 2. So we're looking at 1 and 2. So by the rational zeros theorem, all the possible rational zeros can be found by looking at all the possible p over q. So we look at every possible combination: 1 over 1, 1 over 2, 3 over 1, 3 over 2. So that gives us 1, 1/2, 3, and 3/2. Now that we've found all the possible rational zeros, we use synthetic division to help us eliminate ones that don't work. We need to find some that work. And remember from the synthetic division lesson, a c would be a factor of the polynomial p if the remainder was 0. So we're looking to see if synthetic division results in a 0 remainder. So the only way to do this is to dive in and start testing them one at a time. And I try to stay as organized as possible, so I would start with -1. And set up the synthetic division using the coefficients, and then work out the synthetic. So -1 times 2 is -2, -3, -7, 7, and 4. Once you see that you're not going to get a 0 there, you know that it's not going to be one of your rational zeros, so move on to the next one. So the next one on my list would be 1, 1 times 2 is 2, 5 plus 2 is 7, 1 times 7 is 7, -4 times 7 is 3, 1 times 3 is 3, and there we go. We got a 0. So we know that 1 is a factor. So we can go ahead and say x equals 1 is one of our factors. Now, because this example is a cubic, the resulting quotient is a quadratic, 2x squared plus 7x plus 3. And if we set that equal to 0, then we can use quadratic formula to find any remaining zeros, if they're real. And if they're imaginary, then we'll know that as well. Okay, so x equals -7 plus or minus the square root of 7 squared minus 4 times a times 2 times 3 all over 2 times 2. So x equals negative 7 plus or minus the square root of 49 minus 24 over 4. And then that will simplify into negative 7 plus or minus 5 over 4. So the last two are rational. So we get x equals negative 7 minus 5 over 4 and negative 7 plus 5 over 4. That'll simplify to negative 12 over 4 and negative 2 over 4. So that gives me negative 3 and negative 1/2. And if you look back at our list from the beginning, you see that negative 3 and negative 1/2 were part of that list. So our list of zeros, 1, the first one we found, negative 3, and negative 1/2. Okay, so that one was pretty easy and straightforward. Now as P and Q get larger, it becomes a little bit more challenging. So let's take a look at another example, and I'm going to do a little cheating on this one. I've pre-worked it, but I want you to kind of see, how extensive the list can become. So first find your P and Q. So P is negative 4, so that would be plus or minus 1, 2, and 4. And then Q is plus or minus 27, so that's 1, 3, 9, and 27. So my P over Q list is all the possible combinations of P over Q. So that would be 1, 1/3, 1/9, 1/27, 2, 2/3, 2/9, 2/27, 4, 4/3, 4/9, 4/27. So you can see the list is quite a bit bigger, but we are going to start with the same numbers. We're going to begin with negative 1. Okay, bring down your 27. Negative 1 times 27 is negative 27. Negative 9 plus negative 27 is negative 36. Negative 1 times negative 36 is positive 36. Negative 33 plus 36 is 3. Negative 1 times 3 is negative 3. Negative 1 plus negative 3 is negative 4. And then negative 1 times negative 4 is positive 4, and there we go, got one on the first try. Okay, so start our list. X equals negative 1. Now the problem with this one is this is a 4th degree, so our quotient is going to be a 3rd degree. So I can't use a quadratic formula on the next step to find the next factors, I have to do synthetic division again. And you're going to go through the list, and you're going to find that 1 doesn't work, 2, -2, and you're going to keep going, and until you get to 4/3, you're not going to find one that works. So if you're doing this, totally by hand, which is, kind of rigorous, you would have quite a few things to go through. Okay, so we're going to set up synthetic division using 4/3 and our 27x to the third minus 36x squared plus 3x minus 4. And bring down our 27. So 4/3 times 27. The 3 and the 27 are going to cancel and make 9, and 4 times 9 is 36. And that's going to make a 0. So there's a 0. And bring down a 3, and then 4/3 times 3, the 3's are going to cancel. I get 4, and there's a 0. So 4/3 is my next 0, but this does bring me down to a quadratic. Set that equal to 0, and I can extract square roots on this one. You can also do quadratic formula. Divide by 27. So x squared equals -1/9. And then take the square root of both sides, you're going to get imaginary roots. So x equals plus or minus, the square root of 1/9 is 1/3, so we're talking 1/3 I. So we had 2 rational roots and then 2 imaginary roots. So I try really hard on your exams to pick problems that are like the first example. But your homework is going to contain some of these 4th degrees, so I suggest you use a free graphing calculator like Desmos. If you have a graphing calculator like a TI-83, 84, those are allowed on my exams, so using one of those will help you. You can graph this, find the zeros, as I'm sure you know how to do, but I want you to use that as a way to help you get started. So, find those places where it crosses the x-axis so you can simplify this down to find all the zeros.